Let's talk about something that is, right now, powering almost everything you own. It's in your phone, it's in your car, it's on your desk, but you probably never ever see it. I'm talking about semiconductor chips. They are the tiny, hidden engines of our modern world, and a massive global race to control them is heating up like never before.
Seriously, just think about it. From the second your alarm goes off to the moment you turn off the lights, these little technological marvels are everywhere. We call them chips, but they're technically integrated circuits, and they are the absolute foundation of all modern electronics. You could say they're the brains of the entire operation.
So what are these brains worth? Well, take a look at this number. That's $1,030 billion. And that's the projection for the size of the global semiconductor market by 2030. This isn't just another big industry, you guys. It's becoming one of the most important on the planet.
That massive number really brings us to our first big idea. We're calling them the trillion-dollar brain, but you might as well call them digital gold. Because let's be honest, in the 21st century, controlling this technology is about shaping the future of global power and national security.
I mean, just look at the list. The smartphone in your hand? It's basically a supercomputer packed with chips. Your car? Forget it. It's a computer on wheels, all thanks to chips. And then there are the huge data centers that run the internet and are fueling this AI revolution, not to mention life-saving medical gear in hospitals. It's everything. They are completely and totally indispensable.
Okay, so we get it. They're important. But what are they really? What's going on inside these little black squares? Let's peel back the layers a little bit and look at the actual science in the silicon.
At its heart, an integrated circuit is just a tiny, tiny collection of electronic parts. Before these came along, you had to physically wire every single component together by hand, every resistor, every capacitor. The IC, well, it changed everything. It allowed us to print all those components and their connections all at once onto a tiny slice of silicon.
And the magic ingredient, the part that makes it all work, is called a transistor. The easiest way to think of it is as a microscopic light switch. It can be either on or off. Now imagine arranging billions, and I mean billions, of these tiny switches in super complex patterns. That's how a chip performs the calculations that power our entire digital world.
And the pace of this evolution has just been mind-boggling. Back in the 50s, a chip might have had, a few transistors. By the 70s, we were cramming millions on there. Fast forward to today, and we are packing billions of transistors onto a surface smaller than your fingernail. This incredible growth, this idea that the number of transistors on a chip basically doubles every 2 years, has a name: Moore's Law.
So how in the world do we actually build these things? Well, the process is so ridiculously complex that no single company or even a single country can pull it off alone. It takes a massive, truly global effort to make one chip.
Just look at how this supply chain works. It is incredibly specialized. The initial brain power, the design work, that often comes out of the United States. But the super advanced machinery you need to make the chips, that comes from specialists in Europe, Japan, and the US. Then the actual manufacturing, the really hard part of fabricating the silicon wafers, is dominated by Taiwan and South Korea. And finally, putting it all together, the assembly and packaging often happens in Southeast Asia and China. Every single step is a multi-billion-dollar industry on its own.
So the thing to remember here is that this amazing system didn't just pop up overnight. It's the product of decades of global cooperation and specialization. And for a long time, that interdependence has been the engine of innovation. But as we're about to see, it also creates some pretty big vulnerabilities. And that brings us right to this moment. We are entering a brand new era of super intense competition. That collaborative model that built our digital world, it's now being seriously challenged by a global race for semiconductor supremacy.
So, why the big change? Well, it's a mix of things. Geopolitical tensions have been rising, and recent supply chain shocks really woke governments up to the risks. Suddenly, depending on other countries for these critical components started to look like a huge economic and security weakness. So, the new buzzword is technology sovereignty. Basically, the ability to make your own chips, right at home.
And boy, are they putting their money where their mouth is. We're talking about massive government investment programs. You've got the CHIPS Act in the US, a similar CHIPS Act in the EU, and China's own big fund. All of these are pouring tens of billions of dollars into building up their own domestic chip-making capabilities.
And what's the immediate result of all that cash? A building boom, like we have never seen before. The number you need to remember is 18. That's how many brand new, state-of-the-art semiconductor factories, they call them fabs, are set to start construction in 2025 alone. Each one is a multi-billion-dollar bet on the future.
And this boom is happening all over the world. The Americas and Japan are actually leading the pack with 4 new fab projects each. But you can see China, Europe, and the Middle East are also making huge investments. It is a worldwide scramble to bring chip manufacturing back home and lock down those supply chains.
So, as this whole new global map gets drawn, what does it all mean for the technology itself? Well, let's wrap up by looking at the next incredible wave of innovation that this global race is actually helping to speed up.
The future here is genuinely exciting. We're seeing a big move toward custom chips designed for one specific job, especially making AI way more powerful and efficient. The manufacturing race is pushing us to the absolute edge of physics, down to 2-nanometer technology. Engineers are even figuring out how to build upwards, creating 3D chips that stack circuits vertically for more power. And we're even looking beyond silicon to new materials like silicon carbide, which could be a total game changer for things like electric cars.
And all of this leaves us with one final huge question. This whole technological marvel, this digital world we live in, it was all built on a foundation of global partnership. But now, as this competition gets more intense and every nation wants to be self-sufficient, what happens to the very collaboration that made it all possible in the first place? That right there is the trillion-dollar question for our digital future.